Good morning, everyone. Today, the topic we are presenting is outcome mapping using deep learning. I am Arjun Dashrath. I have Kumari Palak with me, and Aman Singh and Kapil Punia. And we are doing this project under the guidance of our professor, Professor Kuldeep Phule. We are from Army Institute of Technology, Pune. So, okay, let's start with what we are doing exactly. So we know that AICTE OB evaluation has specific outcomes that need to be attained in order for quality education. So we have program outcomes, we have course outcomes, we have program specific outcomes. And essentially what happens is, to give a little bit of context, when students give exams or students have evaluation, AICTE requires the professors to have certain outcomes. Some outcomes are given by the branch, some outcomes are already pre-existing, and some outcomes are very specific. So the professors, when they want to evaluate all the students for AICTE, what they do is they have to map these outcomes to each other, and they have to derive insightful information from these outcomes. Now, Palak, can you move on to the next slide?
Yeah, sure.
So now, what is the problem now? So the first problem that this outcome mapping does is like time. So the time taken for outcome mapping is immense. Like there's a lot of outcome time taking for this outcome mapping. So let's say like there are 12 program outcomes and there are let's say six course outcomes. So if you if you just calculate for every six outcomes, for every program outcomes, you have to calculate their indicators. And let's say if every outcome has five indicators, that will give us almost 12 into like 6 into 5 more mappings. So like a lot of mappings. So we have calculated it, and when professors do on average, they have to do almost 360 mappings. Now to give a little context, what exactly is mapping is that essentially every program outcome has some indicators. So these indicators are like, let's say like this helps in engineering understanding using classes, inheritance, and objects. So one of this might be an indicator. And there are also course outcomes that have certain requirements. So essentially what is required for these mappings is that professors need to use their own logic, and they have to check if the indicator is applicable for the outcome, and they have to map it in the certain way. So the first problem is the time. It takes a lot of time to make so many of these mappings. And the second problem here is it takes a lot of human effort as well. So essentially what is happening now is that professors are using logic for so many outcomes, and it gets really tiring. Like they have to look at each and every thought, and they have to try to make connections that are there, and just give a lot of human effort to make those mappings. And then there is error. So mapping is susceptible to human errors, like incorrect mapping, incorrect data being put, incorrect calculations. So one of the huge reasons that we did this is inconsistency in mappings. So let's say like I am a professor and somebody else is also a professor, and what is happening that I may have some different state of mind, and the other professor may have a different state of mind, and the mappings will be different. Like, or let's say for me as well, if I am doing the one who's doing mappings, today I am in a certain mental space and tomorrow I am in some other mental space, there may be a possibility that I may find hidden connections, or there may be a possibility that I may find missed connections. And in that regard, sometimes I may say that yes, these outcomes are mapped to these indicators, and sometimes I may say that no, these outcomes are not mapped. So there's a general like a problem of inconsistency in all the mappings based on professors, educators, evaluators, and all. And fourth is manual data management. So after these mappings are done, there are a lot of things that are done, like attainment of per outcome for every test or every practicals, exams, and all that. There is also a there also how much attain, like the entire university assessment. There's also college assessment, and there's also the gap analysis as to how many course outcomes and program outcomes are attained. So these were the huge problems that we thought of solving in our proposed system. Palak, can you go on to the next slide? So literature review. So the literature review that we had done was essentially we looked at a lot of different softwares which might have done the same, but currently there were no exact softwares that did AICT outcome mapping. And so we looked for a literature review. We looked at various models and various context matching models that we are going to use. So we'll cover it in the next few slides. So right now, the objectives that we wanted to do was, first, one of our objectives was just authentication. That just for every professor we should have a different compartment and different like workspace where they can authenticate into. And then let's say flexible data entry, like so there are a lot of information that the software needs. So like a lot of outcomes and a lot of specific program specific outcomes also that are specifically defined, that a lot of marks and all students, a lot of weightage calculation. So all these documents we allow multi-format processing, like we take data in multiple formats so that the professor does not have to go to the hassle of converting data from one form to another. Then mapping. So our initial objective is, we have to use some form of contextual matching to map the data with the outcomes and then generate a lot of insights. And there's obviously processing. So we have a lot of calculations, like how many COs are attained and how many POs are attained. So for that we need a lot of not a lot of processing but a lot of precise formula for calculation, and then we need to display all of this in an innovative and a user friendly user interface. So the and so now, like we when we go back to when we go to feasibility, I'd like Palak to take over.
So yeah, as we'll be using the open source framework for building our software like TensorFlow, so it will make our system more reliable. And for the application, we'll be relying on the MERN stack and the Python, as we are more familiar with that and we are more comfortable in performing tasks with that. So for technical feasibility, the all these software and all these technologies are feasible to all the laptops and all the softwares. So it is highly feasible and scalable too. And for the feasible for the financial thing, as we are currently running on the local system, so it does not cost anything right now, but later as the as the production it goes into the production, it will cost about 25 to $50 per month, which will be the cost, which will be the hosting cost for AWS and GCP. So from the initially we'll be talking about contextual mapping and mapping the sentences. So what we are using for mapping and how we are doing it, let's discuss it here. So we'll be using BERT as a mapper, as in model for mapping our two sentences. So what is BERT? BERT is bidirectional encoder representation from transformer. It is considered to be one of the best model to match the similarity between the two systems, two sentences. So what BERT do is basically take the context of a word in the sentence and then map the sentence into the vector space and then let you know whether how much these two sentences and how much these two words are familiar with that. Suppose we have a mathematical we have POs which says that we need to learn about the mathematical engineering student must learn about the mathematical tools, and similarly we have as a CO, as a course outcome, that we learn about how the calculator perform and how the various calculation has been performed. So these two sentences are quite similar. So what word do is basically map those calculation and those calculate word and those mathematical model to, between map those mathematical model into the vector space and then find those mapping and the similar cosine similarity between them. So why we are using BERT? So before BERT, we have also explored some of the alternatives of BERT, that is word2vec and doc2vec, which are widely used by many people. So what happened is that in word2vec is basically represent the word in the vector space, but it does not shows into the context. So whereas BERT is able to do is by having the large data set that it collects from the Wikipedia and various books, whereas in word2vec it does not count into the context and it does not have large corpus to read about. So for example, suppose we have two sentences. Sentence one, it says that it's a fair deal. So here the word fair is highlighted. In the second sentence it says the diggy fair was great. So here in the word2vec, the meaning of fair and the embedding of vector of fair word will be similar, whereas in BERT the vector space of these two fair will be different, which shows the similarity and the dissimilarity between these two sentences and the word used in the context. Similarly, in doc2vec, doc2vec is the extension of word2vec, but instead of word, it maps the whole sentences. But we need a particular word to map it with the sentences so that we could find the internal meaning of a particular POs to a particular COs and PSOs. So we have explored this alternative of BERT. So what are the system requirement that we needed for the running of our software and building it, as we'll be using open source software and it is comfortable with running all the platforms such as Ubuntu, Mac, and Windows. And for the Python, we'll be using 3.7 to 3.10 Python, and we are using various model for the Python, as BERT is highly scalable and can be used by any Python model, so it can be used there. So what is the current flow, like how the flow of our software is currently going is something looks like this. As a user, particular faculty, you have to just log in, and similarly you put your COs and POs in Excel sheet. Instead of that, you can put it in the software. So already POs are already defined for program. So after that, you just have to check it. Okay, these are the POs which is correctly defined. Okay, now next you have to move add to the course objective for a particular course which is already defined, but you have to just check it, like okay, these are the correct sentence and the correct COs, so we can move forward. So next we have to enter PSOs, and all this is fed into our model, which gives the mapping of each COs with a particular POs, and each PSOs with a particular POs. So in a tabular format showing that. So if you feel like that, okay, this is matching with that, then it's okay. If you feel like no, it's not matching, then you can re-enter the data into the model, or you can make it changes according to you. So here is a manual check also given, so that you can check it. Okay, the model is working fine. So currently the model is giving accuracy of 97% after fine tuning. So yep. Now I like to hand over the architecture model for to explain by the Arjun.
Thank you, Palak. So this is how we have designed the architecture. We have a triple layered architecture, which is a bottom layer, it's a middle layer, and a top layer. So let's first start with the bottom layer. So in the bottom layer, we'll obviously have the databases that are used for validation, and maybe in future for future scope, we'll store the context data in the database as well, which we are not doing it right now. Then we have the BERT model. So we have all these scripts written in Python which run on AWS using AWS Lambda functions, and then essentially these models run on the server side and these generate outcomes. Also, we have a lot of metrics calculators, like we have a lot of functions with formulae set up which calculate some of the few metrics that we show. And okay, and then there's the top layer. In the top layer, like we have the login pages, we have the user interactions and data selections, we have the mapping confirmations, and we have the insights display page. And all of this is connected by a middle layer API, which is end-to-end encrypted. So we would like our software to be very secure, and since it's dealing with a lot of marks and results, we would like for it to be encrypted, end-to-end encrypted, so that even we cannot see it. Whatever data will be sent, it will be uh, encrypted with a public key, that and the private key will be only with the teacher, like on the server, on the like client side. And so essentially what is happening is that from the top layer, first auth credentials are being gone through the API to the database, and it's being checked. Then essentially, if it is validated, the user interacts and selects the data, like they put in the outcomes and all. And essentially that data is sent to the server, BERT model runs it, does mapping, sends it back. Now if the user feels that some of the mappings are not in accordance with them, so they can just change those mappings. So mapping confirmation is that mapping confirmation. Once they confirm the mappings, then it goes ahead, calculates a lot of metrics, sends, creates insights, and then sends those insights back. So Palak, can you go on to the next slide?
So, what are the
uh,
scopes and the risks that are involved in our software? Will I be explaining it? So, as we are making a software for calculating the mapping between the course objective and program objective, which will save a lot of time for our administrator instructor, and also help them to manage the learning of an student. Also track them also. So these as AICTS help us to learn through the outcome based learning. So this software will be helping to manage all these learning into a particular software in a one place itself. So the risks that are involved in our software are the firstly is the technical risk. As we all are students, so we will be trying our best to get the best software and the best coding techniques to build the software, but still we might lack in some of the techniques and might lag. So this is something which we'd like to improve. And also we'll be dealing with a high sensitive data. So and the students are these days are getting very smarter, so it's very important for us to save this data from getting into the wrong hand and in the hand of the student, so which so that we could maintain the security of our software. Now the third is the user acceptance risk. As the software will become more complex, the user will be decreasing. So we will ensure that we'll make the software less complex and more usable for the user. So yeah, these are the scope and risk, and here are the some of the references which we'll be using. Thank you.
We would like, if anybody would have questions, we would like to answer them.
Yeah, this is Dr. Krishna Sharma. My simple question, like you have opted really good topic, and this is very much required, especially for academician to calculate the attainment of on the base of course outcome and this program outcomes. So whether this software is readily usable for everyone, or is still some modification or things which is required to add on it?
Uh, Thank you for your question, sir. So yes, we this software is readily usable. So right now we are like still in development. We have developed entirely. We just have to like deploy it, and we have created this software not just for our college, but for the for every stream and for every branch, regardless of what college you are in. And our motivation was to spread it across to everywhere. Maybe make it open source as well, so that everybody can use it and everybody can at least have some sort of this some version of this software for their usage.
Yeah, because especially I am from MBA, so thing is, again, while calculating this attainment of objectives and all this program outcomes, at the end we need to calculate the attainment, and we give the weightage 1, 2, 3, and this depends on us. If one is most important or two is most important. So at the last, the mean is calculated, and later on the final attainment is done. So is it possible this? Exactly what we are going to code, 1, 2, 3 are already coding is done by you, that will calculate the
uh,
attendance of the each student, and what are things. Suppose we are going to calculate the attainment on the basis of class test or
Sir,
assignment.
shall I give you the answer?
Yeah, please.
Sir, actually, this software is fully automated. That is what we are just providing the COPO mapping sheet
Right,
in
right. COP
respect with,
mapping,
yeah,
absolutely.
in form of 1, 2, 3 that you have
Right,
suggested. Then after that, you have to include the student details like marks for the internal as well
right.
as external marks,
Classmate,
both.
internal,
Yes,
right.
both things. Then after that, we must have to get the attainment matrix. That is that particular matrix is attended or not. That one also we get from the software. Also,
Okay.
we show the reports in form of some graphs or some chart. That all facility should be done in this particular software. Yes,
Okay. And in
I
case
hope.
I
we
would
wish
like to
to,
additionally add
yeah,
that like you had said, the weightage is not hard coded. We have a feature where we ask the users for how much weightage, and like for our test we had used that, if we had used some percentages, but they're not fixed, they're not hard coded. We have a such selection screen where we ask the professors to put in weightage and
You
how
know
they
the
want to
weightage of
distribute it.
attainment like 70/30, 60/40, or
right,
50/50,
right.
like that.
Yes,
That
sir.
we must have to ask from the user. We may ask for the user to include that target set or threshold to
Right.
get the
So
attainment.
in case,
Yes.
yeah, one more thing. Suppose that we wish to use your software, so in that case, what will be the mode to at least go for it? So would you like to share this thing also with us?
Yes, sir. Yes, sir. Definitely we will share that. Yes, sir.
Okay, thank you very much. Huh?
Yes, sir. Okay.
Bye.
Thank you,
Thank you,
sir.
sir. Thank you.
Bye.
Any
Thank you,
questions?
sir.